In this video, we're going to do some review of fractions. So let's get right into an example. I want to simplify or evaluate the following expressions. So in A, I want to simplify 12 over 18. So you probably remember with a fraction, if there's some number that divides the top and the bottom, I can just divide that number away. So I know 6 divides both of these. So if 12 divided by 6 is 2, 18 divided by 6 is 3, and that gives me 2 over 3, and now there's nothing else that divides those besides 1. So that's as far as I can simplify this. But why does that work? So why does this work? Let's talk about that briefly. So 12 is 6 times 2. 18 is 6 times 3. And I can split this up now into 6 over 6 times 2 over 3. Right? And then 6 over 6, well, something divided by itself, that's just 1. And then 1 times something is just the something. That just leaves me with 2 over 3. So the 6's kind of go away because 6 divided by 6 is just 1. That's actually why canceling like this on the top and the bottom works. You're secretly creating a 1, and when you multiply by 1, it doesn't change the expression. That's one of the big things that we're going to try to do in this class. As a college level class, we're really trying to move past just what's the process and why does it work now. Okay, so B, how do I multiply fractions? So I can multiply the tops together. That gives me 18. Multiply the bottoms, and that gives me 12. So that's the same as A, just flipped. So if I do the cancellation, divide both of these by 6, I'll get 3 over 2 now. Okay. Another way I could have done this is try to cancel first. So I can do that across any of the numerators and any of the denominators that are being multiplied. So I notice the 2 and the 4 can both get divided by 2, which leaves me with a 1 there and a 2 there. The 9 and the 3 can each get divided by 3, which leaves me with a 3 up top and a 1 on the bottom. Now, multiplying the tops together, I get 3 over multiply the bottoms, and I get 2. And that's my same answer. So 2 ways of multiplying fractions and simplifying. So part C, what about dividing fractions? So you might remember that what we do then is you keep the thing that you have on top, and then you change that division to a multiplication symbol, and then you flip, or you take the reciprocal of that denominator. So times reciprocal, 3 over 10. Okay, and then how does this simplify? Well, with the 5 and the 10, I can divide both of those by 5, which gives me a 1 up there and a 2 down there. With the 3 and the 6, they can get divided by 3, which leaves me with 1 up top, 2 on the bottom. Now multiplying the tops, I get 1. Multiplying the denominators, I get 4. And there we have it. So keep the top, change the division to a multiplication, and then flip or reciprocal that fraction on the bottom. So why does this keep, change, flip work? Again, we really want to think about deeply, why do things work? So if I have this fraction, one thing I can do to it is I can multiply the top and the bottom by the same thing. And what I'm going to multiply by is the reciprocal of the bottom. Let's try multiplying by 3 over 10. 3 over 10 and then a 3 over 10. Because something divided by itself is just 1. And so if this whole thing is 1 and you multiply by 1, it doesn't change the value. That's why this is an okay thing to do. But something very nice happens on the denominator now. These 10s, well, I can divide both of them by 10. So that leaves me with a 1 and a 1. Same thing with the 3s. I can cancel them because you can divide both of them by 3. And I'm left with a 1 and a 1. So that means on the bottom, I'm just left with 1 over 1, which is 1. And on the top, I get 5 over 6 times, and then the flip, the reciprocal of that denominator. And then something divided by 1, well, that's just the something. That is just going to give me 5 over 6 times 3 over 10. Oh, and that is the thing up top times now the reciprocal of the bottom. That is why this multiplying by the reciprocal works. Okay, so what about adding and subtracting fractions? To do that, we have to get a common denominator. Gotta get a common denominator. So what I'm allowed to do is, when I'm adding 2 fractions with different denominators like this, I am allowed to multiply each fraction on the top and bottom by something, as long as what I'm multiplying by is the same on the top and on the bottom. So I can do that for the first fraction and the second one. So it's helpful if I multiply the first fraction, top and bottom, by 2, by this other denominator, because that'll give me a 10 on the bottom. And then I'll multiply the second fraction, top and bottom, by the first denominator, by a 5. Because that, again, it'll give me a 10 on the bottom. It'll make the denominators common. So first fraction becomes 6 over 10. On the second one, I'll get a 5 over 10. And then when you add fractions with the same denominator, the denominator stays as it is. And then you add those numerators together and you get 11. And there's nothing that divides the 11 and the 10 besides a 1, but that wouldn't simplify it. So this is as far as I can go. Okay, what about subtracting fractions? So for this one, I got a 2 over 9 minus 7 over 15. And again, they're different denominators, so I got to get a common denominator. So I'll have to multiply the top and the bottom of each of them by something. And I could do the first one by 15 by the other denominator. I could do this one top and bottom by 9. But that would give me a very big denominator, and I'm wondering if there's something smaller that'll work. So if we can't figure it out quickly, one thing we can do that can help with this is factor each denominator. So I know 9 is 3 times 3. I know 15 is 3 times 5. So this denominator is missing this factor of 5, so let's put that in there. Let's multiply by 5 and then a 5 on top. Now, the second denominator is missing like another 3, like the first denominator has. So let's multiply it, top and bottom, by 3 over 3. And doing that, the first fraction becomes 10 over 45. And then minus, the next one becomes 21 over 15 times 3 is 45. So the denominators are now the same. So subtracting, I get one fraction with 45 on the denominator. And on the numerator, I subtract 10 minus 21, that's negative 11. And in fact, when I have that negative up top, I'm allowed to move it to the front of the fraction. So negative 11 over 45. There's no integer that divides 11 and 45 besides 1, so this is already fully simplified. Okay, so let's up the difficulty. Now I got fractions within fractions. So on the top, I notice I got two fractions added together. So let's add them first. Let's add them first. So I got to do 2 over 3 and then add it to 1 over 6. And then all over that 5 over 12. So what do I multiply the first fraction by? What do I do for the second fraction? Well, I noticed for the first one, I just got to multiply it by 2 over 2 to get that 6 on the bottom. And then I don't need to change the second one at all. Okay, so that's nice. So the first fraction becomes 2 over 6. And then plus a 1 over 6 all over that 5 over 12. So this gives me a 5 over 6 up top over 5 over 12. In fact, let me go ahead and start to simplify that already. So 5 over 6, and then dividing by a fraction means multiply by the reciprocal, so by 12 over 5. Okay, so with the 5s, I can divide each of them by 5 and get a 1 and a 1 left over. With 12 and 6, I can divide them by 6. So I'm left with a 2 up here and a 1 down there. So overall, I'm left with a 2 over 1. 2 divided by 1, that's just 2. Okay, we got it. All right, let's flip the page. Let's do a couple more. So I can also subtract or add fractions when I got variables in them. So I'm subtracting fractions for x over 15 minus x over 10. I got to think about what the common denominator is, and I want to give you a chance to try this. So pause it for about a minute to try this. 3, 2, 1, pause it and try it. This is the most important part of the video. It gives you a chance to see, how well do I understand this at this moment? It's totally fine not to understand it perfectly and to get stuck and to have questions. But it is really important to engage with it, to practice it, because that builds our skills. Okay, let's bring it back. Let's talk about it. So to get that common denominator, multiply the first fraction by a 2 on the top and bottom, because it'll give me a 30 down here. And then the second fraction, I'd multiply by a 3 to get a 30 on the bottom. So then I get 8x over 30 minus 3x over 30. And subtracting, well, I get 5x over 30. So is there anything that can divide the top and the bottom? Well, I can divide both the 5 and the 30 by a 5. So that leaves me with a 1 up top, a 6 on the bottom. So 1x is just x, and then over 6, and there we have it. Okay, so let's end with some examples where we have zeros in them. So what's 1 over 0? There's something weird about this. So to identify what's weird, let's try something simpler, like 21 over 3. So what are we doing when we ask ourselves this question? What this really means is, how many times does 3 go into 21? 3 times what is 21? And the answer is 7. And that's why 21 over 3, we say it just equals 7. If I do the same thing for 1 over 0, what I'm asking is, well, 0 times what equals 1? So 0 goes into 1 how many times? But 0 times anything is just going to be 0, but that cannot be equal to 1. So I get this impossible equation. So I can't really say what 1 over 0 is, and as a result, the best we can do is say it's undefined. We tried to find a value, but we couldn't get one, so it's undefined. So, all right. So that's why if I have 0 on the denominator in a fraction like this, it's going to be undefined. What about if 0's on the top? So if I try the same thing, now I would be asking 3 times what equals 0? Oh, and there is something that works here. It's 0. So 0 divided by 3, it does work. It equals 0. So if you have 0 on the top divided by something else, it's 0. One kind of intuitive example I like to give myself is, when I do a division, imagine I'm dividing dollars among people. So 21 over 3 means $21 divided amongst 3 people. Well, that means each person gets $7. 0 divided by 3 would be, I have $0 divided amongst 3 people. Well, then each person would get $0. But 1 divided by 0 would mean I have $1 divided amongst 0 people. But that doesn't make sense. There's nobody to give money to if there's 0 people I'm dividing it amongst. So that question doesn't make sense, and that's why that's undefined on an intuitive level. And there we have it.